All right, hey everybody. This is part two. I need to apologize. I was rushing through the tail end of that last video because I saw my time was winding down, and I gave the wrong dimension here for number three. The work that I did on a separate piece of paper, um, I actually had 3y plus 2x equals 200. So I was when I gave you that value of 25 for the x value, that was actually wrong. So let me show you that real quick. So here originally I had 25 there. It should have been 33 and 1/3. If you go into the equation here, area is negative 3 halves 100x. If you do the opposite of b over 2a, you'll get negative 100 over 2 times negative 3 halves, which gives you 100 over 3, which is 33 and 1/3. So that should have been that x value of the vertex right here of 33 and 1/3. And then you did get that 1,666 and 2/3 for the value of the area. I did that work up here, just plugged 33 and 1/3 in for x in both of these spots, went through and calculated that, and I got an area of 1,666 and 2/3 square meters. Now the problem itself asked for the dimensions. So we found the x dimension to be 33 and 1/3. If you just use this equation up here of 3x plus 2y equals 200. I did that work right down here to find my y value, then to be 50. So the dimensions, we should have had 33 and 1/3 meters by 50 meters would be that big, this big rectangle here, all said and done. Okay, so sorry about that. I rushed that through that last video. The last one here, number 4, I'll just read the problem first and then go through a little explanation here. A potato farmer has 400 bushels of potatoes, and she can now sell for $3.20 per bushel. For every week she waits, the price per bushel will drop by 10 cents, but she will harvest 20 more bushels. How many weeks should she wait in order to maximize her revenue? So first, for this problem, before we do anything, you just need to have the understanding about what it means. Maybe Maj knows this, but not many others, since he's like our candy lord here. Revenue basically is what you have times what you sell it for. So that's basically the total money that's coming in for whatever your business is and you're selling. Okay, you have 100 pieces of candy and you're selling them all for 50 cents. You know that product will be your total revenue. That's not necessarily your profit, because you don't know how much it cost. You have to take your cost into consideration first. Your profit is going to be whatever your revenue is minus your cost. But if you're just talking straight revenue, it's how much money you get from however much you have times whatever you sell it for. Okay. So in this case, we have R for revenue equals, and then to start, we had 400 total bushels that she sold for $3.20 per bushel. Now, the tricky thing here is, and this is really with any business, as soon as you start dropping the price, you are going to start selling more of the product itself. But as you're if you're dropping the price, you're making less per whatever it is that you're selling. So in here, what we're going to do on the side here, I'm going to say X equals the number of weeks that she waits. So currently she's selling these bushels, she's selling 400 of them, and she's selling them for $3.20. But for every week that she waits, she is harvesting 20 more bushels. So the how many she has aspect of this problem, she's starting with 400, but then she's adding 20 times every week that she waits. So after 2 weeks, it would be 40 plus 20 times 2, which would be 440. After 5 weeks, it would be 400 plus 20 times 5, which would be 500 bushels, and so on and so forth. But for every week that she waits, she's not only adding 20 bushels, but she's also subtracting 10 cents per every week that she waits. Okay, so her total revenue given any week past the starting time, this is what she would be looking at. Okay, and now this is a binomial times a binomial. I can simply just go through and FOIL that out, right? And if I do that, I'm going to get R equals 1,280 is this times this, and do 400 times negative 0.1, 20x times 3.20, and 20x times negative 0.1x, which will give me minus 40x plus 64x minus 2x squared. And now if I clean that up and put my square term in the front, I'm going to get negative 2x squared plus 24x plus 1,280. So now I have that revenue equation that I wanted to maximize as a quadratic equation. Okay, and now notice that the quadratic equation, I have a negative in the front, which means the graph of this is going to open downward. And if I find the vertex of that graph, the vertex is going to be the maximum point. Okay, and with that vertex, you know, the variable that is on this side of the equation, that x value is going to be the x value of the vertex, that negative b over 2a. And then when I plug that back in, what I'm solving for, you know, what we used to call the y value of the vertex now is going to be r. And we said that x was the number of weeks that she would have to wait. R is revenue. Right? At this point, it should be simple. All I'm doing is taking the opposite of b over 2a, which is negative 24 over 2 times negative 2, negative 24 over negative 4, which gives me 6. So that x value of the vertex should be 6, which means she should wait 6 weeks in order to maximize her revenue. Now, that actual revenue, the amount of money she would be bringing in after waiting 6 weeks, you're just taking R and plugging 6 right in for X. Which would give us this, which when all said and done, that would be $1,352 would be her total revenue. Okay, so to answer the question, she should wait 6 weeks, and the total revenue at that time would be $1,352. All right, so notice in all 4 of these problems, whether I was asking to maximize something or I was looking to minimize something, in every single case, we ended up getting a quadratic function. And in all of them, to find the maximum or the minimum, all you simply do is find the vertex. Opposite of b over 2a to find that, you know, quote unquote x value, and then plug that answer back in to find whatever it is that you were trying to maximize. In this case, it was revenue. The time before that, for number 3 and number 1, it was area. And for number 2, we were maximizing the height. We found out what the height was in number 2. Okay, so that wraps up all of quadratic functions. When you finish with this video, you're going to go ahead, you can go through my content library into the lesson plan tab and find the practice problems that go along with this. I will post an answer key to that, to those problems that I want you to do. And then, as I said, later on this week, we will go through some review, and then we will test at the end of this week. I hope to see you all. If you have any questions on anything, you can pop in during my virtual office hours via Zoom that will happen on Tuesdays and Thursdays each of these weeks that we are out. Okay? I'll talk to everybody soon.